So here we have question 7, an above ground cylindrical swimming pool. So the key word there is cylindrical, so it's in the shape of a cylinder, is shown. The internal diameter of the pool measures 8 meters and the height of the pool is 1.35 meters. It is recommended that the pool is filled to 95% of its capacity. So we want to find the maximum volume that the pool is allowed to hold. So the first thing we're going to do is a volume of a cylinder, and the formula for that is equal to pi r squared h. Okay, and we know that pi is 3.14, the diameter is 8, so if diameter is equal to 8 meters, the radius is equal to 4 meters. So the radius, internal diameter is 8, so the radius is 4 meters squared, and the height is 1.35 meters. And on your calculator, so get out your calculator, multiply 3.14 multiplied by 4 squared multiplied by 1.35 gives a total volume of 67.824 meters cubed. Okay, so the volume is in meters cubed. Now we only want 95% of the total volume. So in that case then, what we want is 67.824, multiply that by 0.95, which gives you 64.4328 meters cubed, which when we round, we want the answer in litres. So 1 meter cubed is equal to 1000 litres. Okay, so that's something for you to note. So in this case here, 64.4328, multiply that by 1000 is equal to 64432.8 litres. Okay, and we want to round that then to two significant figures, so 64,000 litres. Okay, is the volume. Okay, that's, just be careful with that. The diameter of the pool is 8, so the radius is 4, and the volume requires the radius. Now, the pool sides and walls, so part 2, are made from PVC. So the sides and the walls, so we want to find the total surface area. And the total surface area of a cylinder is 2 pi RH plus the circle on the bottom, pi RH for the base. So this is for the side plus the base. Okay, so in this case here, 2 times 3.14, the radius is 8 and the height is 1.35 plus 3.14 times the radius is 4 squared. So let's do that out in our calculator. So 2 times 3.14 multiplied by 4 should be 4, multiplied by 1.35, which is equal to 33.912, plus multiplied by that is equal to 50.24. Add the two of those together, and we get a total of 84.152 meters squared. Okay, so just be careful. The diameter is 8 meters and the radius therefore is equal to 4 meters. So just be careful with that when you're substituting in for the radius. Okay, so that's question 7. For question, we have a cone then, question 6. So we're looking for a space module consists of a cone on top of a cylinder. The radius of both is 4. The height of the cone is 8 and the slant height is 5. Find in terms of pi the total volume. So the total volume is going to be the volume of a cone plus the volume of a cylinder. Right? So the volume of a cone is 1/3 pi r squared h, and the volume of a cylinder is pi r squared h. So we have a cone, and we know that the radius is 4, and we know the slant height is 5. But what we need to find is we need to find h. So we're going to do h squared plus 4 squared is equal to 5 squared. H squared is equal to 5 squared is 25. Take away 4 squared is 16. H squared is 9. So h is the square root of 9, which is 3. Because we need the height for the cone. So the volume of the cone is equal to 1/3. We're going to leave pi as it is. The radius is 4 meters squared and the height is 3 meters. So we're multiplying that out. So 1/3, leave pi in terms of pi, and we get 16 pi meters cubed. And for the cylinder then, pi again is pi. We know the radius is 4 meters squared, and we know the height is 8 meters. Let's multiply again, and we get 128 pi meters cubed. So the total volume will be equal to 128 pi meters cubed plus 16 pi meters cubed, which is equal to 144 pi meters cubed. Okay, so that's the volume of a cone and a cylinder. And then lastly we have a cylinder with some tennis balls wedged inside. Okay, so this one is more tricky for you. So a tennis ball has a radius of 3.5. So part 1, we want to find the volume of the ball. And the ball is in the shape of a sphere, so the volume will be 4/3 pi r cubed, which in this case 4/3, we want it in decimal, so 3.14, and the radius of the ball is 3.5 centimeters cubed. So on our calculator, 4/3, 3.14 multiplied by 3.5 cubed gives me 179.50 centimeters cubed, correct to 2 decimal places. So the volume of the ball is straightforward enough. Okay, part 2 then, we want to find the height of the tube. So we want to find the total height, h. So what we do know is that the radius of each ball is 3.5. Okay, so radius of each ball is equal to 3.5 centimeters. So the diameter will be equal to 2 times 3.5, which is 7 centimeters. And we're going to stack 3 balls, which will be 3 times 7 centimeters, which will be 21 centimeters. Okay. Part 3. We're looking for the radius of the tube. So the radius of tube will be equal to, well, we know the radius is going to be 3.5 centimeters. Why? Because the width of the ball is equal to 7 centimeters. Okay? And finally, not finally, we want to find the volume of the tube. So the volume of the cylinder tube, the formula for the volume, pi r squared h, 3.14. The radius is 3.5 centimeters squared, and the height of the tube is 21 centimeters. So 3.14 by 3.5 squared, multiply that by 21, is equal to 807.765 centimeters cubed. So that's the volume of the tube. And finally then, the fraction of volume taken up by the balls. Well, the balls take up, so there's 3 balls, is 3 times the volume of each ball is 179.50 centimeters cubed. So 3 times 179.50 is equal to 538.5 centimeters cubed. So 538.5 as a percentage of 807.765 is equal to, as a fraction. So 538.5 as a fraction of 807.765 is equal to 0.66 or 2/3. So that's the fraction, 2/3.